So thanks for coming. It's the end of a long day, I'm sure, for most of you guys. I'm going to be happy when this is over. I don't know about you guys. But so I'm here to talk about certainly IronRuby. I've got a theme in my talk that's going to kind of interweave itself throughout the different demos I'm going to show you. And it's this combination of simplicity and platform. And to try and kind of kick off this idea of simplicity and platform, what I wanted to do was kind of take us a little bit back through memory lane, at least for me. Back to your first computer. This was my first computer. And this was perhaps one of the last times that I actually understood how one of these things actually works in any detail. So what's awesome about the internet today is not only can you go off and find pictures of your old computers, but you can also go off and find emulators for your old computers. So what I have here is a working Commodore 64. That still works if you still remember sys64738 like I do. Now, this was where I started with computing. And like a lot of folks of my age, which I'm now dating myself, you know, the nice thing about this was the interactive experience, right? We had this ability to simply walk up to this thing and type print 2 plus 2, and it would give me some really strange answer like 22. So I guess this has got to be a bug in their emulator. So I guess it's not perfect. But, you know, if you don't mind getting wrong answers occasionally, this was a great way for you to experiment with programming, right? You could type a line of code, see something happen virtually right away. And there's something that's really kind of visceral about this immediate feedback, right? So you're not sitting around waiting for things to happen. I don't know about you guys, but when your build kicks off, right, you tend to alt-tab off to something like programming in Reddit, and maybe 20 or so minutes later, right, you know, your build takes 3 minutes, right, but 20 minutes later you get back to doing what it was that you're working on. So I wanted to spend a bit of time inside REPLs to kind of, you know, start off our talk and to show you, you know, a few little small one-liners about Ruby to kind of show partly our .NET integration pieces and partly just some kind of cool little one-liner things we can do just to warm us up. How many people here write Ruby code? Actually, so let's do the inverse. How many people don't write any Ruby code in this room? OK, so for a lot of you guys, right, this will be kind of interesting then. So let's start off our Ruby interpreter. And let's you know, obviously things like this will actually give us the right answer, right, in this thing. But one of the first things that you're going to want to use IronRuby for is to integrate with .NET stuff, right? You know, like otherwise, well, why would you use it? So if you want to integrate and talk to .NET libraries, we have a mechanism whereby we use the same mechanism that Ruby uses to load a module, a Ruby module, to load .NET assemblies. So we go off and we say require MS-corelib. You know, that comes back and we're now in business, so to speak. So if I include the system namespace, this is the moral equivalent of a using inside of C#. I can now do some stuff like enumerate the constants inside of this namespace. Now, constants in Ruby are kind of constants, right? Anyone who knows the difference, there's a subtle difference. But constants in Ruby are used to identify classes for the most part, right? So as you can see there, those are some of the classes you might be familiar with, and namespaces as well out of the system.NET namespace. Now we can do some other things as well. So certainly I can go off and let's just retrieve some subset of these class names. So I can say class names is equal to the original system.constants, and I can grep through this thing, right? So I can grep it using a regular expression inside of here, and I can say, please give me all of the things that start with A to C, right? You know, so I can go off and do some of these kind of filtering operations. Now, we can do some more things than just a simple filtering operation where I pass a regex into some API. I can also go off and do some transformative things. These are constants, and if you're to walk up to one of these guys, like class names.first.class, you'll see that it's a string, right? It's just giving me the constant names back. if I want to evaluate these things to kind of dereference the constant, so to speak, right, to get at what it references, I need to first eval these things. Right? So if I want to get a collection of all of the classes, right, I can do something that looks like this. I can say class names dot map, and I can build this little transformative function where I just simply iterate over each one of these guys, eval that string, right? And that's going to give me back something else. Let's go classes, right? And now each one of these guys, if we inspect them, classes.first dot, in this case here, we can see that this thing here is actually a class, right, that I've gotten back here. So I've evaluated the results, and I've done this nice little one-line, transformative function there. Now, what's interesting is that, system access violation exception is a .NET type, so I can go off and not just look at the Ruby view of the world, which is what I'm doing right now when I dot into its class property. I can also call a little transform function to CLR type, which will retrieve back for me the CLR type of the underlying thing. Once I've got the CLR type of the underlying thing, I can now invoke methods like, oh, is this an interface, for example? And that returns false, as you would expect. All right, so this just kind of warms you up to kind of show you some of the simple little things and the little one-liners that you can use in Ruby, and also getting to see this interactive thing, right? The interactive thing is very powerful. Being able to just walk up to something and poke at something and see what happens is something that, personally I find very satisfying about the language. So let's kind of get out of here for a second. Let's go back to the slides for a minute. And I want to just kind of lay out the map for the next few demos that I want to show you. Ruby is a scripting language, right? And scripting languages historically have been used to kind of glue together stuff, right? And generally the things that we glue together were written in C, right? Back in the good old days. Nowadays, the things that we're gluing together more often than not are things written in managed languages of some sort. And so Ruby certainly can be used to go off and do these kinds of system administration or scripting tasks that you find. But you can also certainly go off and use Ruby to build entire applications as well. So what I wanted to first show you is some simple examples of Ruby in a scripting kind of a role. I want to show building some kind of reusable service, right, using Ruby as well. And most of the times, these kind of reusable services that we have are web services of some sort, right? They listen on HTTP, they give you results as HTML or something else that you want to, throw down the HTTP protocol. And what I wanted to show you is this really, really simple micro framework inside of Ruby called Sinatra. And Sinatra is a very simple web application framework. There's lots of web application frameworks in Ruby. Sinatra is about 1,400 lines of Ruby code, thereabouts. And the interesting thing that you'll see is it kind of harkens back to this simplicity theme. We're going to build a web service entirely inside of one file, and we're going to be able to run the service and interactively edit the thing while we're writing the code, right? So you get this kind of no compile. You don't have to stop the service, compile it, and start it back up, right? But I can just edit the thing live, right, as I'm building my service. And then finally, before we get there, there's going to be a bunch of these little kind of hippie moments, right, kind of sprinkled in, right? So let's get back to the demos. So the first thing I want to show you is Flickr. Now, as you all know, right, Flickr is this photo sharing service, and there's lots and lots and lots of libraries that use the Flickr web service effectively as an API that you can go off and mash things up. That photo that I showed you with all the little pictures there, those were actually, if you squinted and if you looked really closely, those were actually Fibonacci numbers inside of a Fibonacci spiral, right? That was created by a little script that walked up to Flickr to grab a bunch of photos tagged with the actual number, so you can get a picture of the number 33, right, or 13 or something, right, and drop it back into your app. So while we're not going to do something quite as ambitious right inside of this talk, what I wanted to show you are these libraries, right? Like often you hear about this great thing Flickr, and you're saying, man, wouldn't it be awesome if I could go off and just build an application that talks to Flickr, right? And then you go off and you go find some library somewhere on the internet, right? And here's a library that I found, which is a FlickrNet library, which lives over on CodePlex. You can download the sources or the binaries, whichever meets your fancy, and you can start building code that runs against this thing. But of course, when you learn a new API, right, it's always frustrating, right? Because there's all these things that you got to learn, and you got to create some objects and stuff them with a bunch of things, and a big part, for me at least, when you're looking at these kinds of APIs, is I like to kind of transform them into something else. Like, how many people here are guilty of writing wrapper classes, right? Like, certainly everybody, right? And part of the thing that you do while you're writing a wrapper class is trying to grok the API, right? The act of writing the wrapper class is informative, right, in its own right. So what if you could kind of do both, right? You could write wrapper classes, but while you're figuring things out, let's figure it out by interactively poking at things, rather than, in this case here, here's an MSDN doc that shows how to go off and use this thing, reading through a bunch of code examples, and then having to kind of cut and paste this thing into some other app, and then run this thing in this app and compile it. There's friction involved in the learning process. Right? So the goal here is to try and reduce that friction in the learning process by as much as we can. So let's go off and do that. So if you look in here, flickernet.dll is the assembly. And let's open up this flickr.rb file that I want to start off with. And there's some key. All right, so if any of you guys have ever used Flickr before, you basically sign up for a free account on Yahoo. And at some point in time, it says, give me a key, and it gives you a key, and it gives you this scary-looking number. And you just kind of paste it into your application. This is what they use to kind of track your usage of how you're using Flickr. So let's just write our first little wrapper around this thing, right? You know, just so I don't have to type that number in over and over again. So what I need to do is require the name of this assembly, which is flickernet.dll, right? So I can just go say require flickernet. So once I've got that guy in, let's include the flickernet namespace, which is where all of the types for the Flickr library live in. And let's just define a simple little function called Flickr, which simply news up a Flickr object, right, defined inside of the .NET assembly, and we have to pass in the key, right, in order to make it happen. So with that little bit of scaffolding, so to speak, out of the way, we can now come back in here and start our interpreter. So once we've got our interpreter running, we just need to now require Flickr now, right, which brings in that library. And once I've got that library running, I can now go off and do stuff against it. I can Flickr dot into stuff, right? Now, let's go back to the docs for a second, right? So we can see some of the things that we need to do in order to actually go off and find things. So let's find the thing where you do the tags thing. So if you look at the text there, let's zoom in a little bit here so you can see that a little bit better. So we have to create this photo search options object, right, and stuff a parameter into the tags property of this thing in order to go off and do our search. Right? So we can certainly go off and do exactly that inside of our REPL loop. So I can just simply say $options is equal to photo search options.new. So I construct one of these objects. .options.tags is equal to PDC 2008. So if you go to Flickr, you'll find that the photos from this conference are all being tagged by the people that care with the PDC 2008 tag. And once I've got that, I can walk up to the Flickr object or the Flickr method in this case here, right? Remember, I defined a method called Flickr inside of this other file here, right, which simply news up the object and returns an instance of the new object. So I can go Flickr dot, and then I can do a photo search. And I can pass in, the options thing that I just retrieved. And let's assign it to another variable. Let's call it $P. And this will actually go off to Flickr, do this query, and return back to me the results of this query. So now that I've got this thing here, I can say $R is equal to $P dot photo collection, which is actually the array, right, which contains the first 100 results from Flickr. So now that I've got this, I can inspect some of the properties. One of the properties I can look at is $R.first. Remember, this is an array, so I can walk up to the first element inside of the array. $R.first.medium URL will return back to me the URL of the photo, right, that we want to go off and retrieve. Right? And I have this other fun little library, require image show, that Jimmy in the front row just wrote for me just now, where I can now walk up and say show photos and pass in $R.first.medium URL. And what that'll do is walk up to create a little WPF application, also written entirely in Ruby, that grabs that photo and renders and displays it inside there. Right, so it's kind of cool, right? You can sit down and build this thing. But once you're done building this thing, once I've kind of recorded a sequence of steps, right, that I want to now, create an abstraction for, I want to create a method, right, that kind of does those set of things, this is now where we get to see some of the funky things we can do in Ruby. So let's exit out of here for the time being. Let's come back here, and let's take a quick peek at this assembly. So if we take a quick peek at this assembly, you can see that here's Flickr net, and inside of this assembly are where the different types are, right? So there's the Flickr class there, and there's also a photo class, further on down that we can go off and manipulate. I want to introduce you to this really funky feature inside of Ruby that has its own name. It's called monkey patching. Now, the interesting thing about monkey patching is, since I have this view of the world now, and this view of the world is from Ruby. I have a view of the .NET world. The .NET world is still a statically typed world, right? That hasn't changed, right? But what I can do from Ruby is I can change the Ruby view of that world, right? And if I change the Ruby view, I can do things like add new methods to existing types, much like you can via extension methods inside of C#. And I can also go off and change existing implementations of methods and wacky stuff like that. So let's go off and do some of that stuff so we can kind of take what we've learned and codify it inside of our application itself. So if I create a module called FlickrNet. Now this module here is what we use to define namespace-like things inside of our .NET interop code. Right? It turns out that namespaces in .NET map exceedingly well to modules inside of Ruby. Now I can go off and open up the Flickr class. And by opening up this Flickr class, I can define a method. I can define this find by tags method, which takes some set of tags as a parameter, and we can now just essentially type in the stuff that we had before, right? Photo search options.new, options.tags is equal to tags, photos search options, right? Passing in that options object, and I'll just retrieve the photo collection property now, without having to dereference it one more time to get that collection of photos. And now with 3 lines of code, I've now got a simpler API, right, for going off and using it in the scenario that I happen to care about in this case. Now, similarly, class photo, right, I can add a show method, right? And inside the show method, I can simply go off and call show photos and pass in medium URL, right? Show photos, as it turns out, can actually show more than one photo. So I can pass an array of these URLs for it to go off and render. Last thing I'll need is to require the image show module as well. And so with all that in there, I can now essentially do the same thing all over again, right? So let's go RBRI. Let's require Flickr again. Now I can go Flickr.find by tags, right? And I can pass in PDC 2008 as a tag. There's my photos that come back. And as it thinks fit, there we go. We have our photos now. I can go .p.first.show, right? And that same sequence of things that we did before, right? I've now kind of remembered what those things are. And so this style of programming where you interactively explore an API and then you take the results of what you've interactively explored and you shove it into a method, maybe even modifying the original API, is something that's a lot of people find particularly productive. And it kind of harkens back to this simplicity theme, right? There's nothing quite as simple as typing a line of code, running it, and seeing what the answer is. So that's how we can think about doing this Flickr stuff. Let's get back out of here. So there's that. Now, the next thing I want to show you is also something that I find is probably quite simple as well. And I want to show you Sinatra. Oh, I should reset Sinatra. So with Sinatra, it's a web framework. And it's a web framework that allows me to essentially, in a single file, define these little handlers, right, for the different types of HTTP requests that I want to return, want to write some handler for. So if I open up app.rb, this is essentially the starter of most simple Sinatras applications, right? The first line of code require Ruby gems. Ruby is a package management system, right, called gems. And gems are nice in the sense that the packaging system has this global directory service. I can grab a gem by name and do gem install Bob, and it'll go off and grab the Bob gem and drop it down to my machine. I'll require Sinatra, which itself is packaged up as a gem. And I'm just going to set this option right now for the web server that I want Sinatra to use is this thing called WebRick, which is a built-in all Ruby web server. What's interesting about the way Sinatra and a lot of these micro frameworks in Ruby are designed is that they layer on top of something else. This something else is called rack. And rack is an abstract interface over a number of different web servers. Right? So there's certainly, it's entirely possible for us to go off and build a rack handler that's going to allow us to walk up and map this to IIS or to Cassini or whatever web server that you want to use as the thing that dispatches the requests into Ruby. So now there's quite something rather satisfying about being able to write hello world like this. Right? That is hello world inside of Sinatra. And let's just make it do something a little bit more dynamic, right? So we'll print out the current time as it does this. So if I come back to here, and rbri app.rb. So I'm just going to go off and run Sinatra, which will go off and boot the WebRick server here. And let's switch back over to here. The WebRick server is going to start up on port 4567. Thinking. Oops. Hello. Okay, I'm not. This is starting on 4567. What happened to my web browser? What happened to my web server? This thing started. It's not setting something weird. Okay, let's shut down this and let's try again. Spooky. Okay, so I blame IE, right, for that. So what we have is, it goes off, it does a thing, right, prints a timestamp, and it's about the simplest possible thing that you can imagine doing, right, inside of a web server. Now, that's all it could do. It wouldn't be particularly interesting. But notice here that I'm going to keep this thing running. I'm going to go back to this file, and let's just add some more stuff, right? So let's have it say hello, well, to somebody, right? So hello name. I can do something like this, right? Now, in this case now, I can simply say hello. And this stuff comes back out as params in a params collection. Name, like so, right? So if I come back to here, whoops, and I say John, right? As the thing here, it says hello, John now, right? So I've added a method to this thing. I haven't had to compile. I didn't have to stop my server, right? It just keeps on going. Right, so we can do some really kind of funky things in there as well. Now, let's do some other perhaps more ambitious things than simply going off and getting the name. One of the things that I've always found frustrating about the MSDN online documentation is that there's a lot of stuff that I don't care about, right, inside of the docs. Right? What I care about is I want to know the remark section, right? Generally, that's the part that I generally really care about because I want to know the things that aren't obvious by looking at the signature in IntelliSense. All right, so let's say that I want to go off and build a simple little service that walks up to the MSDN web service, right? Passes in some search term, and then gives me this kind of simplified view of the world, right? That'd be kind of cool. So if we come back to here, what I want to show you is so an old friend of mine, Craig Andera, I don't know if Craig's here, but maybe he'll be watching this on TV someday. But Craig wrote this thing called MSDN Man, and it lives up on MSDN. So this is another example of where I can go off and steal this other guy's code, right, MSDN Man. I had to repurpose it a little bit because it wasn't quite factored out to be a library. Wrote a simple little .NET wrapper around the guts of it, which does all this scary XML stuff. And then returns the results back to my Ruby application in a simple object that I can then consume, right? So that's what I did, was I went off and grabbed this thing, did a little bit of massaging of it, and let's kind of take a look at what it looks like. So we're inside of, where am I? Proxy. So actually, no, let me show you MSDN lib. So this is the project that I grabbed from Craig's application. And I kind of refactored everything out, and now there's this little thing that I call the API class, right? This kind of wraps all of the scary stuff that's inside. Now, the interesting thing is MSDN results, right? You can see MSDN results simply returns me this struct-like thing that has a title, a summary, and a remarks out of the MSDN documentation. Down here at the bottom is a static method that we use to go off and search based on an identifier, and it goes off and does some scary stuff inside of Craig's code with XML and returns me back this object, which I can now manipulate inside of Ruby. Right? So that's all this guy does. We come back here. Let's take a look at, let's see, Sinatra. That's what I want to look at. Oops, do I already have this open? Aha. No, I want to keep this. Do I really want to write to it? Yes, yeah, thanks. Okay, so what I want to do now is grab a set of search terms, right, that I want to pass as a pretty looking URL, right, to this application. So I can say def get msdn/html, right, give me the results as HTML in this case, /star, do. So that simple thing will simply return back to me the rest of this thing. I'm going to define a simple little helper method up here called getSearchTerm, which is going to scrape out what's inside of that star. Because as you imagine, the URL is going to look something like string or system/string, right? Will be, you know, the thing that's passed into me that I have to parse, right? So obviously I want to simply translate that slash into a dot, right, when I'm searching this. So I go params splat, as that thing is called, right? Dot toString first. And I'm going to call this translation method, which is part of the Ruby standard library, which say translate all of these guys into this, right? So I have that. So inside of here, I can now, let's just say, you know, looking for, just to make sure this actually works, get search term, right? I have that. Now let's go back to our service again, and let's run that. So it's msdn/html. So let's go look for system disposable. So we're going to be looking for this thing, right? Okay. So now we know we have the right search term inside of this. So now what are the last couple of things that we need to do? I need to require that assembly, which lives in this place, debug msdnlib.dll, right? So I have that guy. I need to include his namespace, which is msdnman. And so down here, what I want to do is I want to grab, you know, that particular object. So I can do so by msdn man api.search. Right, that's calling that static method, right, that I had before. I'm going to call get search term as this thing down here, right? That's going to grab that guy. And now I've got this results object. Now I want to do something with this results object, right? I want to print this out, but really it's got, you know, 3 fields, and I want to kind of inject it into some template, right? So clearly I want to do some kind of templating thing. Save a little bit of time. I've already written a template under views, msdn html template.erb. ERB is also part of the Ruby standard library. It's a simple templating engine. It looks very ASP-ish in its way, right? So it's just less than % equals, and then some Ruby expression, which gets evaluated at runtime inside of that, right? So as it turns out, there's a nice little helper inside of Sinatra, which makes it very easy to integrate ERB in. So I can say ERB, the name of the template. So this is going to be MSDN HTML template. Right, first thing, locals is equal to this thing here, where doc is set to this guy here. Right? So let's go to, I can get rid of that. So let's read this from left to right. First parameter is the name of the template for it to go off and look, right, inside of the views directory. The second parameter is assign local variables. Right? If you look inside of here, doc is a local variable, right, inside of this template. Right? So what I'm going to do is essentially lift or assign to a local variable in a different context inside of the template context, the object that I retrieved from the MSD and searchlib function. So once I have that, with any luck, when I refresh that, we will see an error, of course, right, because I typed something wrong. So let's come back here. See, the awesome thing about this is, no, maybe not. Okay, now what's happened? So param splat that, TRS, translate this thing, ERB this thing. Pardon me? No, 2S definitely works on that. Do I blame IE again? Let's see. Looking for, ooh, this is spooky. Oh, I know this one. Okay, so the problem is when you change the routes, right, in that kind of wacky fashion, right, the route caching table got confused, I'm pretty sure. So let's go off and run this guy again. And we'll switch back over to here. And once we've started up again, why are you still saying looking for? Did I save the file? Where am I? PDC Sinatra. And this is PDC Sinatra. And we'll try one more time. Ah, yeah, you have to save the file, right? So you can see here that we now have the ability to kind of just have this slightly prettier, right, version of this thing. Now, of course, somebody with some talent, right, can go off and make that look a bit nicer. Now, so that's pretty interesting, right? I can build these simple services. I can integrate in with some .NET code, and it's this simplicity thing all over again, right? If all I want to do is something simple, I should use a simple tool, right? And this works extraordinarily well for those kinds of things as well. All right. Okay, so moving along, let's go and take our intermission. So what I want to talk quickly about is some of the hippie stuff that we do on our team. As hopefully most of you guys are aware, or some of you are aware, IronRuby is an open source project. We get questions like, when are you going to ship IronRuby? And the answer is, well, we kind of shipped it yesterday and the day before and the day before, right? If you go off and grab our sources off of RubyForge, right, you can get our daily builds, you can build this thing and run more or less maybe 24, 48 hours in bad cases, right? Sync difference between our internal repository and the external repository on RubyForge, which is where we publish all of this stuff. Now, the interesting thing about the Microsoft public license is that it basically means that you don't own a squat. That's kind of the legal definition of it. And so you can take this code and do with it whatever you will, right? You can take this code and fork it. You can build your own private build of IronRuby. You don't have to contribute your changes back if you don't want to, all right? You could take it, stick it in a box, and sell it if you wanted to, right? So pretty well anything that you really want to be able to do, you can do with this code. Now, what's interesting is that the reason why we wanted to go off and distribute not just the source code for IronRuby and release it under the MSPL, but also the DLR, which is the foundations upon which IronRuby is built, the source code for that is also released under the Microsoft public license. So what this means is that we really want to try and encourage a language ecosystem to build up around the DLR itself and the CLR by extension. And we want to make it as easy as possible for people to do this, right? We don't want to have some arbitrary thing that says, nah, I don't want to do with this thing. We'll use something else. Now, what this has gotten us is that if you look at where IronPython, this is the Synaptic Package Manager inside of Ubuntu, right? And you can see that IronPython is available for you to go off and grab, right, as part of the standard Debian distribution that Ubuntu is a downstream thing from. And this is IronPython 1.1 running on top of Ubuntu. So the nice thing is that people can take our code and ship it. Now, Miguel de Acaza over at Novell, as part of his Mono project, has spun up another project called Moonlight. So Moonlight also is essentially Mono 2.0, or the Mono runtime, that runs inside of your browser with the media APIs for Silverlight in there as well. Right, so certainly, because our code is released under the Microsoft public license, they can package up the DLR languages, right? Ruby, Python, whatever they so choose, and simply ship and distribute that stuff, right? Which is a nice thing to have as well. All right, so back to the platform stuff. So now I wanted to show you integration with perhaps some richer platforms that we have inside of .NET. So the first thing I wanted to show you is how you can take your Ruby programs and embed them inside of your existing C# application. Right, so maybe you've got an existing application that you want. Maybe it's your people out in the field, right? Or maybe it's even your customers, right, to go off and write some scripts against. Right, so you would expose some kind of programming model as part of your application, and you would hand that over to the script writer as an application object, let's say, and they can go off and program against that inside of whatever DLR-based language that they want to do. So I'm going to show you how easy it is to do that inside of IronRuby. Next thing I want to show you is Visual Studio. So how many people here have ever written a Visual Studio plugin of some sort? Oops. Yeah, thank God. Yeah, so you guys know some of the pain, right, that's involved in that. So the awesome thing about what I'm going to show you here as part of this demo is we can have this interesting interactive experience in building a Visual Studio plugin inside of Ruby. Right? Because none of that crazy, I got to recompile, shut this thing down, and all that other stuff. Right? So I'll show you some of that. And finally, the obligatory Silverlight demos, right? Which always show up in all of my talks. Okay, so we'll get to that guy later. All right. So let's kill Sinatra because I don't need him anymore. All right. So the next thing I want to show you is a REPL. Right? REPLs are lots of fun. So let's start up this guy. This is a WPF application, and let's just run it so you can see what it looks like before we go off and add our funky things to it. So all this thing does is accept some input here. When I hit Control-E, it echoes it. Right? Nothing particularly exciting about this yet. So what I want to do is I want to add IronRuby integration into this thing so that it's going to take whatever the user typed inside of that WPF application, eval it or run this thing, and print the result back out onto the console as well. All right, so let's see what we have to do in order to make that happen. So what I want to do is define a little class up here to kind of encapsulate the things that I want to do with Ruby. So I'm going to create a Ruby engine class. And inside of Ruby engine, I'm going to have a private field, which is going to hold on to script engine, which we're going to create inside of the constructor of this guy. So inside of the constructor, I can say engine is equal to ruby.createEngine, and we can pass a number of different parameters to this thing. Now, certainly I can pass it nothing, in which case it's simply going to go off and initialize using a set of defaults that we're going to give you already. Or what we could also do is something perhaps a little bit fancier. And in this case here, I'm going to go off and define some options, right, that I want to initialize my engine with. And in this case here, what I want to say is the options are interpreted mode is equal to true. Right? So we're going to set this thing up to be start off in interpreted mode. Now, IronRuby is a compiler. By default, if you run it off the command line, what it's going to do is read your source code files in. Right? And when methods are executed, right, it's going to go off and compile these things down in IL and execute them. If you run inside of interpreted mode, what it does instead is it interprets the DLR trees that we make. Normally, we take the DLR trees and we compile them into IL. Right? But in this case, we have this recursive descent interpreter that will simply interpret the DLR trees instead. What you get in terms of a trade-off there is you get faster startup time, right, in exchange for poor throughput. Right? So nothing in life is free. So once we've got that thing set up, I have that, and we finished initializing our engine in this case here. Now, the next thing I want to do is create a method that's going to execute the code inside of a string. And again, that's as simple as saying returning engine dot execute the code. There, okay? So there's our simple little encapsulation of this, and we can tweak it with some more options and stuff later on if we want to. Now I need to go off and create one of these guys here, so let's create a field, private Ruby engine. Let's call it Ruby. And Ruby is going to be a new Ruby engine in this case, right? So we're going to construct that guy there. Now, if we look down here towards the bottom of this thing, in the key down event, there's my little handler for Control-E, right? And you can see that Control-E, what he does is he's got a little insert text method in here. What I really want to do is I want to, instead of inserting some text there, I want to eval the code, right? And then insert the result of the evaled code, right, into the result. So let's do something simple like that. So in this case, I want to say Ruby engine, Ruby dot execute, right, the code that the user typed in, which is in code text box dot text, right? Not template. Okay, so I have code text box dot text, and then I want to simply go off and insert text, this guy there, right? Oh yeah. So this thing here, of course, is returning me something of type object. This thing's expecting a string, so I'm going to toString that guy and get back in here. So if I now take this thing and run it again, I can go 2 + 2, in this case here, and it's going to go off and print the result of executing that code there. Right? We can do other things, like I can go, John.reverse, right, just to show this isn't just a calculator. And, all of Ruby is now available inside of the simple REPL. And it only took a few lines of code for you to take our Ruby engine and embed it into an existing C# application. So that's pretty cool as well. All right. Now, so what about Visual Studio? Certainly, a lot of folks would be very interested in using IronRuby inside of Visual Studio. Some people are not, right? But you get to pick which kind of tool that you want to use, to go off and write your Ruby programs. But what I really want to show you here, which is something I think is particularly interesting, is the ability to write extensions in Visual Studio using Ruby, because that's kind of cool. Right, because again, it's much like that Sinatra experience, right, where I had app.rb and I can edit this file live without having to shut everything down and see what the results of that wind up looking like. So, let's go into VS, and let's go into Ruby console app 1. Now, what's interesting about Ruby console app, let's look at this directory first. You'll notice that we have a .rb proj here, right? So what we've done is the beginnings of our Visual Studio integration work, on our team. So we have Ruby projects, and we've got, rudimentary syntax coloring and some other things inside of this thing as well. So you can see here, I've got this, simple little Ruby program that doesn't do anything right now, sitting up inside of Ruby Visual Studio. Now, what I wanted to show you are some fairly interesting things and I'm fascinated by using Ruby as a way of driving tests, right, inside of your C# code. So Ruby makes it very easy for you to build these test frameworks, especially given our .NET integration, that you can certainly use to test Ruby programs, but you can also use it to test .NET programs as well. So let's imagine first what some unit tests might look like. So here's a simple thing that's going to test adding, let's say. So let's say that I want to say should equal 7 as a result of this, right? So you can see that this is a simple method. Test add, 3 + 4 should equal 7. So in some ways it's very nice. It reads from left to right. Now if you're not familiar with Ruby, that might look really weird all of a sudden, right? So I've got this expression, right, that I've just evaluated, which is obviously going to be some number, right, at the end. And now I'm going to call a method called .shouldEquals on that number, right, which might be a little bit unusual. So let's fill in the blanks here so we can finish our unit testing framework. So there should equal other, right? Right, so we've got our little unit testing framework, right? Really simple, right? But you can see that everything in Ruby is an object, right? That's one of the observations that you see here. So what I've done is I've opened up the object class, and I've added this should equal method, right, to all of the objects, right? So now, as a result of running this expression, we're going to see that, these things should equal. And let's, call a method inside of this thing. We'll control F5 to run this thing. Oops, I didn't print the result. All right, but if I run this thing, it says true, right, which is what we would expect, coming out of this. Now, like a lot of unit testing frameworks, it would be kind of cool if I could right-click on the method, right, and say run this method, or run this test, right, inside of that. So let's do that next. Let's open up a file, .whack add-ins. And I've got a simple little skeleton of, this is some highly experimental code that Oleg on my team hacked up on Friday, right? But what this does is it's a very simple plugin that passes in a little bit of interesting context to us, right? So context.activeDocument, ActiveMethod, and ActiveClass will tell you what the user just clicked on inside of Visual Studio, right? So if I know what the file is, and if I know the class and the method name, right, I know all the things I need to do what? Load that Ruby file and eval the method that you clicked on, right? So we're going to do exactly that. So coming down to here, first thing we're going to do is load the file that we got there. Next thing we're going to do is expression is equal to, now here's a little bit of, trickery, right, if you will, right? Because as you can imagine, I wrote that thing, that method wasn't inside of a class. It was at top-level scope inside of that function, right? So class in this case is likely going to come in as nil. So I just want to simply go off and test for this. So to make this slightly more general, method.name. So if class.nil, I need another question mark on this guy because I want to write a ternary expression. If I want, if class comes in as nil, I want to just execute the method name that was passed to me. And if class wasn't nil, then obviously I need a slightly more sophisticated expression where I'm going to say class.qualified name.name, colon, method.name, right? And once I've got that, I want to eval that expression and pop up a message box, right? So let's go messagebox.show. The answer is, and let's eval expression, like so, okay? So here's the kind of fun thing that can happen here, right? I'm going to right-click on that, run test, right, is run test that we see there. We click on that, and the answer is true, right? And if we change this, right, we would expect that the answer is false, right? So that's pretty cool, right? Again, I have a Visual Studio add-in that I wrote kind of on the fly, right, with the file open inside of a text editor, just modifying the code inside there so you can go off and build these extensions. Now, I think it's highly likely that if it was this easy to go off and build extensions to Visual Studio for macro expansions, other crazy stuff that you might want to do, right, that you might actually do it, right? So a lot of this is back to the simplicity theme, right? Let's try and make, simple things simple, right? And clearly, adding something that triggers inside of Visual Studio should be something that's relatively simple for you to go off and do yourself. All right, so there's the VS stuff. Now, to kind of, run along with this testing theme a little bit more, what I want to show you is two more things. I want to show you a slightly, let's see how we're doing for time. So 6:04, now I have to do math on the fly, right? Am I 50 minutes into my talk right now? Do I have 15 minutes left? 10 minutes left? I have until 6:30. Yeah, okay, yeah. But then the recommended thing is to leave 15 minutes. Yeah, okay. So, all right. I will skip the first thing, and I will show you the second thing. The second thing, I think, is perhaps a little bit more interesting. I'll show you the answer for the first thing, just so you can see the first thing that I wanted to show you. I wanted to show you a simple unit testing framework, right? And this is the dream. The dream is at the bottom, right? It knows how to add 3 plus 4 dot should equals. Instead of that kind of ugly underscore equals thing, I put a space and equal there, right? Now, there's a couple of interesting observations here. First, equals equals isn't an operator inside of Ruby. Equals equals is a method call inside of Ruby, right? So I have the ability to redefine what this thing means. So if you look at this, right, 3 plus 4 dot should, so I'm adding a should method to object here, right? And what should does is it creates a new matches object passing itself as a parameter. And what matches does is it stores it away as the left-hand side, right? I implement equals equals, right, on the matches object, passing right-hand side, right? And I do something here, right? Print a dot or an F, right, depending on whether or not the test passed or failed. The last little bit of trickery that I'm going to show you here is it, right? So it knows how to add. So you know that, in most of your unit testing frameworks, right, you're used to coming up with some mangled method name, right, for the text that you want to say, right, instead of just putting the text there. Right, so in this case here, all we're saying is it, some text. Right, and my unit testing framework, when it runs, will say it, blah, 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 blah. What yield does is it yields to this block. And a block is the code that's begin between here and there, right, the highlighted stuff there. So that block gets yielded to, it executes, and then it returns, and I print out the final character term. Right, so that's all this thing does. And if I run the framework, it knows how to add. The first thing would pass, right, if you go back to the original test. 3 plus 4 is 7, but 3 plus 4 is not 6 in the second case. Right? So we can go off and build these very, very simple unit testing frameworks because we have all of these interesting metaprogramming facilities. And we also have the ability to make things look clean and pretty. One of the things that you discover if you look more at the Ruby community is that there's this really kind of strong sense of aesthetic in the community. People will start yelling at you on mailing lists if you case things the wrong way and things like that, even if it's perfectly valid Ruby syntax. But there's also this, this emphasis on clean and easy to understand code at the same time. So, things like this, the small increases in readability that you get by being able to write expressions that look like that is rather important. It's very important to that community. This is just a subset of the syntax in a much larger Ruby library called RSpec. And RSpec does this with all sorts of crazy reporting options and the rest of that stuff. And IronRuby today can actually run RSpec with, I think, one modification right inside of RSpec. Right? So we're getting close to being able to run really complicated. RSpec is a pretty complicated thing. So with one local mod, that's pretty good. All right, so we have framework. Now, the other thing I want to show you is mocking. Right? Because here's some kind of funky, wacky things that we want to be able to do. So let's look at model first, because I want to show you some C# code for model. Now, up at the top, I have an iCalculator, so I have an interface, right? It has an add and a multiply method. I have an implementation of a calculator that knows how to add and multiply. And I have a program here, which when you run it, will take an iCalculator instance, right? And use it down here when I call the run method to go off and do some math, right, in this case. Okay. So some of the things in these kinds of systems is you might want to decompose these things so I can mock out what calculator does, right, if it was something more sophisticated than a calculator. I can mock this thing out, and maybe what I would like to do is record the method calls, right, that my program is using against this thing, right, so I can use it to verify that the behavior of the system is what I'm expecting it to be. So how would we do something like that? So clearly what we're going to need to do inside of Ruby is create a Ruby calculator, let's say, right, that's going to mock mock the iCalculator interface, right? So how would we do that? Mock 1, oops. I'm in the wrong directory. So there's mock 1. So what I'm going to do here is I have an iCalculator interface. I'm going to include iCalculator. Right? So again, what we're finding is this is something that matches quite nicely with some existing Ruby semantics, which is implementing an interface is like including a module. Right? And so what I'm going to do is I'm going to include iCalculator. I'm going to define this little private method that just records stuff, right? And it's going to return some bogus result, 42 at the end. Right? And there's add and there's multiply there, which simply delegate or forwards the call, right, to the record thing. Right? And if we run this thing, you'll see that it's going to print back out, right, the method calls that that it saw, and then print out the result of what run returned to us. Now, if you look at that code, that looks a little bit ugly, right? Because you're saying, all I'm doing is writing kind of this generic forwarding thing, right? I'm just forwarding these method calls. So wouldn't it be kind of interesting if I could reflectively do the same thing, right? Because all I would really need to do is walk up to the iCalculator interface and say, hey, what are your methods, right? Get your methods and define some forwarding methods on the fly, right? So we can do exactly the same thing here as well. So let's look at mock2.rb. And up at the top there is our forward interface. So let's walk through this code line by line to see what it's doing. Now, the first thing here, let's see the usage of this. I'm just going to forward the interface to a method called record, right, or record. And the interface I want to forward is called iCalculator. All right, so here's forwarding the interface. There's star interfaces. That's a splatting operation. So I can pass in an array of these things. It's like a param array in C#. Here, I'm going to iterate over each one of the interfaces that was passed to me. I'm going to include that interface, right, so that my Ruby class is going to now implement that guy. I'm going to do a little bit of guarding here to make sure that this is actually an interface that the guy is trying to forward. And then here, what I'm going to do is I'm going to use reflection now, right? So interface.methods false. .methods is a reflection API inside of Ruby, which will return back to me a list of all the methods that are defined only in that type and not in its base types, right? So true and false means, do I include my ancestors, right, in the list? So I'm going to say false. I just want the things to actually defined by the interface. And now in this line of code, here's where the magic happens. So first thing is I'm defining a method called method, right, which is the method that I'm now I'm getting by iterating over all of those methods. Star args, again, here's a splatting operation. So this will work for any number of arguments that's passed to me. I'm going to send, so I'm going to dynamically invoke the method named target again. Right? So remember, target was passed in as a parameter in forward interface way up here at the top here. Right? So I have target there. And once I've got target there, it just goes off and invokes the method. Right? So it does all of this kind of forwarding stuff. So all I have to do is implement this thing once, right? And I can have this much nicer behavior there as well. As you can imagine, I could abstract it away. I could abstract that thing away as well if I wanted to, right? But I'm just going to leave that there for clarity. So if I rbri mock2.rb, not very exciting, it's going to say exactly the same thing as the first thing did, right? But now I've got this much cleaner way of doing this kind of interface forwarding stuff. So those are some of the funky things that we can do with mocks. Now, let's go back to the slides. Oh, no. Silverlight. Can't forget Silverlight. So let's go to Silverline demos. Notice that this is code Azure, right? Almost, right? And that it's completely accidental. Okay. Let's see. Localhost, :3000. Yeah, let's just pull this guy up. So these are obligatory Ruby things. So some of the, oops, I'm doing it in the wrong browser. Jimmy, you should have warned me about this. You saw me opening up the browser. Okay, so localhost, there's a weird HTML issue, which we need to fix. So what this will do is it'll go grab Silverlight, download to the client, start this thing up. We can see IronRuby is now running inside of here. I can do 3+4. I can go, Jimmy.reverse, right, to make the thing at the bottom happy. So, this is the same kind of thing, right? But the cool thing about this is IronRuby has now been streamed down to the client and is now executing inside of your browser. And it executes, cross-platform. It runs on Mac. It runs on Windows, obviously, in various browsers, including Safari, Firefox, Internet Explorer. With the Moonlight stuff, when they get the Moonlight 2 stuff written, you can run wherever Moonlight can run as well. Right? So there's going to be a lot of kind of funky things that we can do with being able to run Ruby inside of the browser. I think there's a lot of interesting opportunities for doing even DHTML programming, to use an old term, right? Entirely from Ruby inside of the browser, if that's the language that you would prefer to write things in rather than, say, JavaScript. So we've got our quick thing there. This. OK. So it's timely, right? So what can you do for IronRuby, right? IronRuby is an open source project. Right, so as an open source project, we welcome any and all contributors. There's lots of different ways that you can help us figure out what we can do with IronRuby. So some of these things can be coming up with interesting scenarios for us to think about. Right? The best way for you to come up to us and tell us about some scenario is prototype it. Right? There's nothing better than showing some piece of code that says, I could imagine doing something like this. Right, to perhaps drive where our priorities are and how we want to think about building things. You can also walk right up and get your hands dirty and write some code. Right? I'm going to show you some numbers shortly about how far we are in terms of our implementation. One of the nice things about Ruby is there's lots of implementations of Ruby now. Right? There's at least 6 or 7 funded implementations depending on how you count them. And all of those implementations today are now sharing a common Ruby spec test suite. And that test suite is used to essentially verify that this Ruby implementation actually is Ruby. Right? So the tests are trying to verify it's obeying the language semantics, and it's also trying to verify that the libraries that you've written, and generally for most of these cases, since the large part of the standard libraries in Ruby aren't written in Ruby, they're written in C. Right? Those things have to be ported to whatever the implementation technology of that Ruby implementation is. So that library also helps you, or helps us certainly tremendously, in verifying or doing this test-first style of development, for our own library implementation. So, libraries. OK. So the thing that I wanted to show you next is briefly how you can go off and add a method to our libraries, right? Just so you can see, roughly how complicated this thing is, and also why you might even want to do this, right? So there's this why question, which I think is really important to answer. And then there's a secondary question of, well, how do I do it once I understand why I would need to do something like this? So let's go back to here. So if I look at calc, so step 1 here. You guys are going to be sure that this is the only code I know how to write, a calculator. So there's a C#-based calculator. And that C# calculator here was compiled into calc.dll there. And I have calc.rb as well. And there is a Ruby calculator. OK? Now, let's require each one of these guys and look at some interesting observations. So for the C# calculator, let's require calc.dll, right, which is the name of that guy. And once I've got that, I can go calc.new.add. Well, let's do this, because I'm going to want to call them a few times. C.add 3 and 4. Right, so that works. Right, so you would expect that to work. Let me bring up another console in parallel here. Oops, I need to get out of this guy. And I want to go to calc. RBRI, calc. So I'm going to pull in the Ruby file in this case. And I'm going to say $c is equal to calc.new in this guy. $c.add 3 and 4, right? So that's going to work too. Okay. Now what happens, I got to remember, this is calc.dll. Okay. So $c.add, what if I do this? I'm going to steal this from Jim. So if you went to Jim's talk, you know what the answer to this is, right? Right, it's some crazy number, right? Okay? And if we go off to our Ruby calculator and ask the same thing, right, you get the right answer, right, for some definition of right. And so this is why, right, you might need to care about some of this stuff, right? because clearly, this is a case where if the thing that you are requiring or importing into Ruby that you want to consume, if you're perfectly happy having that thing behave like a .NET type, right, then you're fine, right? You can just go off and use that thing. If you want that thing to feel like it's a Ruby type, right, for all the crazy, wacky things that you can do inside of Ruby, right, you're going to need to do something a little bit different, right? And so this is the case where you now need to kind of roll up your sleeves and write a Ruby-compatible library that you can now use. So what I want to show you next is how we go off and build one of these guys. So I'll pull up our solution, which, oh my God. Oh, that's right. I haven't loaded this thing inside of this world. I run inside a special demo boy account, right, for this thing. So this is a little bit different. So use calcops.cs. Now, in the interest of time, I'm just going to go off and pull out the solution for this guy here so that I'm not going to type all this stuff in front of you. So let's go back to calc. Inside of here. So inside of here. Let's pull that guy out here, paste it into here. So I want to show you a few things. Now, the first thing I want to do is I'm going to hide all this if false. Let's not compile this stuff first. So let's look at how we would, in a very simple way, go off and implement a calculator, right, that's going to behave like Ruby. The first thing that you might imagine is we're going to need to have this thing which takes a couple of integers, right? So that's fine. Our implementation has to, of course, obey integer math, and we'll do x plus y, but notice that we're doing a checked add in this case. In case we have an overflow exception, we're going to overflow into something else. We're going to catch the overflow exception, and we're going to call our big integer add stuff, right? So we're now going to go off and expand the result into a big integer and return that result back to the caller. Some of the other things that you might imagine, Ruby also, that same Ruby method also works with doubles, right, on floating point numbers and returns the correct result. So we're going to need an overload that works with those types. And down here, we could potentially be passing just big integer types into Ruby itself, right? So we need to go off and do this add operation as well, okay? So if we were to compile this guy here, we're going to get a compiler, which I will fix in a second. Oops. What am I missing here? Oh, I hate it when I paste code in the middle of nothing. So I don't think it's that. I'm missing one here. Yes. Okay. So this thing went off and compiled. Now let's actually, no, it did something bad. So let me fix this something bad that it did first. So this is something that if you worked on our libraries before, you're going to run into this issue. So we code-gen a bunch of stuff for our initialization. So this is essentially how we create all of the tables that we need to go off and say, okay, this thing has this method, and it maps to this .NET method, and so on and so forth. Since this is all generated code, it's perfectly okay for you to delete everything inside of this file. And, oh, no, bad, I'm doing this. Okay, so while it's compiling, we can go to programming Reddit. No, okay, hold on. No, we'll come back here. We'll build this way. This is much faster. So I have this. So I now have this thing compiled. Now let's go back here and see whether or not our newfound thing. Now notice here that I've created a class called myCalc, right? And for simplicity, this is now a built-in type inside of Ruby, so I don't have to require anything, right? myCalc is just available to my Ruby program. So I can say, oops, RBXI, oops, RBX. Let's do this. Ah, yes. So I did that. Next thing I need to do is I need to rebuild that file that I just deleted everything in, right? So let's go back to that thing. So you can do that. And now I need to compile this guy again, right, to catch this. So now that I have this thing in here, I can go myCalc, $C.add, 3 and 4, right? So that works, $C.add. right? So that now gives us the right answer as well. And $C.add 2.0, comma 4.0, right, also gives us the answer. So we can see all of those different overloads being exercised inside of this thing. And so that's one of the reasons that you might want to do this kind of stuff. But there's a trick. There's a catch here, which is why there's a step 2 in this. Oops. So let's look at IronRuby mischief. See what I did in IronRuby mischief? I've redefined what plus means, right, on fixed num, right? And I've changed it to a minus. Now, as you might imagine, right, with IronRuby mischief, we have a problem now, right, with our implementation. And our problem really is that if you look inside of our C# code, our C# code is using this hard-coded C# operator, plus, right, and calling methods called add, right, which is wrong. So in this case here, what we need to do is we need to dynamically invoke a plus method on the object, right, that's passed in, that's on the left-hand side of the expression, right? That's how we would wind up getting the right result there. So coming back to here, we would make this work, right, by simply false, right? I will just uncomment out this guy here. Something doesn't look right there, but yeah, fine. We'll do that. So that's okay. Oops. We'll build this guy. We'll come back to here, rake gen this guy. Come back there. Yeah, fine. Okay. And now that we've got that guy, where am I? I'm in here. So we can now rerun this IronRuby mischief thing. And we get the right answer. I should have run it before, giving you the wrong answer, right? But actually, no, that is the wrong answer. It should say -1, so I did something horrible here. What did I do that was wrong? Oh, no, I did. Let's really compile it again. No, I'm compiling the wrong project. Hold on a second. I mean it this time. Okay, so it's doing its thing. And we'll come back to here. Oh, there's something bad. Okay, what did I do wrong? This does work. Really? Oh, wait. I'll show you I'll cheat. Because I haven't rebuilt the release version. Oh, damn. Okay. All right. I will fix that bug. There's something that broke in there. I almost made it to the end, right, with everything working. Okay. So let's close up. We've only got a couple minutes left. Some numbers I want to show you, because numbers are always very interesting. This is our current Ruby spec pass rate inside of the standard libraries themselves, which are the things that you don't have to require. So all the built-in types, we're passing currently at a rate of 78%. The numbers that are small that are hard to read is 13,000 some odd out of 17,000, right, for a pass rate of 78%. We're at greater than 91% on the core language specs, which is actually higher since we fixed a few more bugs just over the last few days. Now here are our performance numbers. So this is a measurement of throughput. The benchmark, the things aren't really particularly important. Green is good, red is bad. This is the standard Ruby 1.9 micro benchmark suite. Ruby 1.9 is the next version of Ruby, and the Ruby 1.9 folks are using this micro benchmark suite to tune their implementation. So you can see that we are better on some things, we are worse on some things. We really haven't done any specific optimization tuning, right, outside of some things around startup performance so far. We really want to make sure that we get the language correct first, right, before we go off and work on that. But those are pretty gratifying numbers in the case that, for, the majority of the benchmarks, we are actually running rather well. Some of the things, one of the bad ones there is regex, for example. So there are things that we know that we can certainly improve our implementation on, down the road. Okay. So there's this. So one of the other really awesome things about IronRuby is it's small. if you use 7-zip to compress our binaries, our release mode binaries, it weighs in at 1.4 meg right now. So it's a very, very small install. This is essentially a fully featured Ruby with not just the built-in libraries, but all of the Ruby standard libraries, all the ones written in pure Ruby itself, right? Also packaged inside of that thing as well, right? Our goal is over the next few weeks to get to a point where we can release a meaningful beta of this thing. A meaningful beta is one that can run gems, right? So we're still blocking on a few things around gems right now. But the minute we can start running gems, we're going to release a binary build for you guys to start poking at, because that becomes a lot more interesting, right? Because you can now gem install a whole bunch of different things and start playing around with stuff and then finding bugs in our implementation and reporting them back to us. So definitely, we're making some pretty good progress there. One last hippie moment. It's this thing. So sometimes you need to optimize for different things, right, when you're building your software, right? So clearly job one is shipping, right? You got to ship the thing first, right? But once you have shipped the thing, you now have this opportunity to look back and say, what are the other interesting things that we could do, right? So my argument is that all things being equal, right, that you're likely to be more productive in a dynamically typed language than in a statically typed language, right? So if you want to optimize for productivity at some phase inside of the development cycle of your application, build it in a dynamic language. Use the various things, the little techniques I showed you, right? Interactively building things, poking at things, wrapping them up inside of different scenarios. Once you've got that stuff working, you can start to optimize it. Now, the interesting thing about the optimization stuff is that IronRuby makes it very easy for you to take that code that used to be Ruby and move it over to C#. Right? And as you start moving the bits and pieces that might be critical, it might be performance critical code. It might be code that it would make sense for you to run a static verifier over, for example, right, to perhaps catch more bugs than you would otherwise. Right? So there's lots of reasons for you to perhaps start moving things over. Now, the interesting argument about this is that these other languages are faster, which you can also translate into more efficient. Right? So all this cloud stuff, right? We're all talking about the cloud nowadays. So with the cloud stuff, you can imagine that you're now paying for wall clock CPU hours, right? So you now have this built-in incentive, right? Financial incentive to optimize for the number of wall clock CPU hours that you're now paying for, right? So this get it right first, right? Then make it fast thing, right? Certainly what we're doing with IronRuby can also be used inside of your app. That's a stunning statistic there, by the way, right? Which kind of shocked me, And it's rising, which kind of shows that, and a bunch of other things. So coming to the end, remember the kind of themes about this is simplicity and platform, right? You want to try and do things in as simple of a way as you can. I think IronRuby really gives you the opportunity to go off and do this interactive style of development, as well as taking what you've learned and shoving it back into some set of scripts. I want you to let us know, because we really care. This is how to reach me, certainly, and how to follow the kind of things. There's Twitter stuff, there's a blog. We're very interested in hearing what you have to say about IronRuby, right? What you see us doing well, what you see us not doing well as well. We have these wonderful conference evaluations. This is a really good opportunity for you to go and fill in things, right? Both ways, right inside of the conference evals, to say, what are the things we're doing right? What are the things you'd like to see us do? Are you happy with what we're doing? So that's a great way of getting us feedback, certainly here, but certainly if you wanted to delay it later until you've had a chance to play with the thing a little bit more, right, there's lots of other channels there that you can use to find and reach me. Okay. So I think I've run right up to the end. I'll stick around for some questions if you guys don't want to rush off and eat and drink and do stuff yet, but thank you.